If you drive on a modern highway, there's a good chance you're actually resting on a layer of asphalt that sits right on top of stones laid by Roman engineers 2,000 years ago. It's wild to think about, but those roads were meticulously planned, drained, and built to last, using these heavy stone layers to survive the brutal shifts in weather. But here's the thing. There's a paradox here. We usually imagine a rigid, secret formula for why they're so durable. You know, the common belief that Roman roads were built with a deep 3 to 6 foot trench filled with specific, uniform layers, that's actually a myth. This rigid model, which describes layers like the statumen, rudis, nucleus, and pavementum, is often attributed to the writer Marcus Vitruvius. But in reality, the Romans didn't just build one kind of road. They developed 3 distinct types: the atat for foot traffic, the actus for pack horses, and the via for wheeled traffic. So does the legendary durability of these roads come from a rigid formula, or from a flexible, pragmatic approach to engineering? Now, imagine the scale of the disruption to the landscape. The process started with the army and engineers deforesting a wide strip of land to clear all the vegetation, basically stripping the earth raw. Once the land was clear, workers removed the topsoil from the projected track, scraping back the upper layers until they hit a solid base. In places like Britain, this often meant digging a wide, shallow ditch to reach the bedrock. And once the stable ground was reached, the first structural markers were placed. Curbs were set on the solid base according to the chosen width of the road plan. These curbs didn't just mark the boundary, they effectively locked the entire construction into a fixed engineered width, which ensured the road wouldn't spread or buckle under the weight of thousands of marching soldiers. Once those curbs were set, the actual engineering began. The foundation of large stones was laid down between those curbs to serve as the base. This first layer, known as the subgrade, consisted of large stones or gravel to provide a stable base and distribute the weight of traffic evenly. Then, on top of this, the Romans added layers of smaller stones mixed with fine aggregates to fill every single gap. This second layer, the base course, was composed of smaller stones or gravel, which were compacted to create a smooth surface and provide additional stability. To move these tons of material, they used tipper carts, driven by men and animals, which moved along already compacted layers to deposit material for the next stage. Every load of gravel and sand was spread out with planks, watered from barrels, and then compressed with heavy rollers. Finally, the Romans reached the surface course. This third layer was made of sand or lime to fill the remaining gaps and provide a solid surface for travel. The final surface layer was a mixture of gravel, sand, and clay, using carefully selected materials of the highest quality. And in some cases, this surface layer was reinforced with Roman concrete to make it an even more durable all-weather road. For centuries, historians accepted a very specific image of how these roads were built, but it turns out that image was actually born from a translation error. In 1622, a man named Nicolas Bergier mapped the Roman Empire in a massive 2-part, 1,000-page document called L'Empire de Romain, commissioned by the French king. The problem is that Bergier based his technical descriptions on a misunderstanding of an older text. He looked at the writings of Marcus Vitruvius, but Vitruvius wrote about building foundations for villas, not highways. The confusion stems from the word pavementum, which simply means floor. In 1617, Bergier confused this with the French word pave, meaning stone or paved road. Because of this linguistic slip, a set of instructions for a house floor was treated as the gold standard for a highway system. This single mistake created a myth that lasted 400 years and convinced the world that every Roman road followed a rigid, deep-layered formula that the Romans themselves likely never used. Looking at the actual archaeological evidence, the reality is far more flexible. The choice of materials for Roman roads varied based on location and the way resources were available. They weren't following a rigid blueprint, they were adapting. Take Britain, for example. The common image of the entire Roman Empire in Britain being paved is a myth. While paving was more common in towns, cities, and near forts, the main roads outside these areas were often just gravel or compacted earth. Beyond the materials, the Romans incorporated specific additives to enhance durability. In areas with volcanic activity, they used pozzolana, a volcanic ash that, when mixed with lime, created a hydraulic cement that could set underwater and was incredibly resistant to weather. This means the roads weren't just stone on stone, but a chemically bonded architecture. And it wasn't just about the materials. The Romans didn't simply build on top of ancient trackways. While some larger routes like the Fossway or Watling Street may have followed ancient paths, the wider network was a planned system connecting major settlements across different tribes. This means the roads were surveyed and mapped out before a first stone was ever laid. It was a calculated, strategic move to consolidate power across a diverse landscape. Just reflect on the sheer ambition of the Appian Way, the route known as the Regina Viarum, or the Queen of Roads. This wasn't just a path, it was the first major paved route of the Roman world. Construction began in 312 BCE under the direction of Appius Claudius Caecus. To understand the scale, look at the original stretch. It connected Rome to the city of Capua in south-central Italy, eventually extending 162 miles, roughly 261 kilometers, to reach Tarentum, now known as Taranto. To put that in perspective, that's roughly the distance from Rome to the outskirts of Florence. When you see these distances, the concept of over-engineering starts to make sense. These weren't just local paths. They were high-speed arteries designed to move legions and trade across an entire peninsula. To achieve that legendary straightness, the Romans used a specific surveying tool called the Groma. The agrimensores, the specialized surveyors, used this device to set a route against a fixed point in the distance, such as a beacon. It worked simply. Plumb lines hanging from a cross allowed them to align the road perfectly. We know this because a complete Groma was found in the remains of Pompeii, providing the concrete archaeological evidence for the tool's actual use. By prioritizing straight alignments, the Romans preferred to build straight roads whenever possible. This wasn't just about aesthetics. The straightest route was a strategic choice to reduce travel time and facilitate faster travel and easier navigation. While the roadbed itself required solid foundations, the precision of the Groma was the key to ensuring the road actually headed in the direction intended. Now, contrast this with the landscape of pre-Roman Britain, where routes like the Harrow Way and the Pilgrim's Way were characterized by zigzagging paths that followed the contours of the land. The Romans didn't just build roads, they imposed a geometric order on the wild. When you look at the Portway, for instance, which connects London, Cirencester, and Dorchester, you see the hallmark of their strategic choice, a line that cuts straight through the terrain. This wasn't about a dogmatic obsession with straightness, but about efficiency. By reducing the distance, they ensured that troops and messengers could move with maximum speed, and that defense was simplified. The straight line was a tool of empire, a physical manifestation of Roman authority over the geography of the province. Looking at the cross-section of a stone-paved road, you'll find it wasn't flat. The final geometry had slightly sloping sides to allow rainwater to drain outwards. This slight slope, known as the camber, ensured that water didn't pool on the road, which would have eroded the surface. To bind the materials together and create a smooth surface, the Romans added lime to the mix. But the engineering didn't stop at the surface. Parallel to the road, they dug ditches. These ditches acted as a security measure, used to prevent access by unauthorized vehicles. These ditches also cleared the area around the road, which increased the visibility of the peripheral view. This was a strategic move to ensure travelers could spot potential threats or wild animals before they became a surprise. To grasp the actual magnitude of this operation, look at the numbers. The Roman Empire's road network spanned over 250,000 miles, stretching across Europe, Asia, and Africa. To put that in perspective, that's roughly 400,000 kilometers of connectivity. If you laid these roads end to end, they would wrap around the Earth's equator 10 times. Now that is an incredible amount of connectivity. While only about 74,600 miles, or 120,000 kilometers, were high-quality stone-paved roads, the remaining 90,000 kilometers, roughly 50,000 miles, and another 80,000 kilometers of gravel tracks created a seamless web. This wasn't just a path for soldiers, it was a service industry. The system included essential traveler services like inns, horse-changing stations, and way stations to keep the empire moving. More importantly, this extensive road network allowed for the creation of detailed maps, which fundamentally aided in the administration of the empire. There is a persistent, almost seductive myth that links our modern trains to the ancient world. The theory that modern railway gauges, specifically the 4 feet 8.5 inches distance between the rails, were derived from Roman war chariots is false. The claim suggests that Roman wagon wheel spacing was tightly monitored to avoid breaking wheels in the paved ruts of the roads, which supposedly dictated the rest of history. But the reality is far less linear. In the UK, for example, the early railway years saw the use of a wide variety of gauges, not a single Roman standard. The idea that a chariot's axle was the blueprint for the modern locomotive is simply an urban legend. Most of us assume the Romans had a bird's eye view of their world, but the reality was far more linear. For moving army units or government workers on the Cursus Publicus, the Romans used itineraries rather than large maps for navigation. These lists of distances and landmarks served as a practical, one-dimensional guide to the empire's arteries. It creates a fascinating contrast. While their engineering was three-dimensional and layered, their navigation was a sequence of instructions. We are left wondering how a traveler in the 2nd century could perceive the rest of the empire when their entire journey was defined by a single, straight line of text. Roman roads were not the product of a rigid, secret formula, but the result of a pragmatic, flexible approach to engineering. From the gravel tracks of Britain to the paved arteries of Italy, the Romans adapted their materials to the soil and the terrain. They didn't just build paths, they integrated drainage, the strategic surveying of the Groma, and the camber to create a system that survived for millennia. The legendary durability of these roads was not found in a deep 6-foot trench, but in the Romans' ability to adapt. By turning a landscape into geometric order, they physically manifested Roman authority over the geography of the province. This leaves us with a lingering question. As we build our same modern highways, are we still following the same pragmatic logic of the Romans? Or have we simply replaced their stone and lime with asphalt and steel?